If you wanted to describe your car to someone, you probably wouldn't want to give them every detail of your car's appearance because it would be an overwhelming amount of information and the person probably wouldn't be able to picture what your car looks like. Instead of giving the person every detail of your car's appearance, you would probably just tell the person the make, model, and year of your car. That way the person could picture what your car looks like just using those three pieces of information. Just like how you wouldn't want to describe every detail of your car's appearance to someone, you wouldn't want to give someone your entire spreadsheet and tell them to look over all of your data values, because that would also be an overwhelming amount of information. You have to calculate values that can summarize your data set so that it isn't so overwhelming. Just like how the make, model, and year of a car summarize the car, there are values that can be calculated to summarize a set of data, and those values are called descriptive statistics. So descriptive statistics are values that are calculated to summarize a set of data, and there are three major types of descriptive statistics that we'll talk about. One type is called measures of central tendency. These values are meant to show the center point of the data set, which is the point that has half of the values below it and half of the values above it. The median is always exactly at the center of the data set because the definition of the median is the value that has the same number of values below it and the same number of values above it. The mean is the average of the data, and the mean usually comes out somewhere near the middle of the data, but not exactly at the center. And the mode also tends to come out somewhere near the center of the data because if imagine I recorded the exam scores of a class and the lowest person got a 65 and the highest person got a 95. The mode of the data would be the exam score that appeared the largest number of times, because the mode is just the value that appears the largest number of times. The mode probably isn't somewhere down by the lowest value of 55, and it's also probably up near the highest value of 95. The mode is probably somewhere in the center. For example, maybe 75 or 77 might be the value that appeared the largest number of times. So the median is always exactly at the center of the data, and the mean and the mode tend to be close to the center. That's why they're all called measures of central tendency. Some textbooks will just call them measures of center. There are also values that measure the dispersion of the data set. Dispersion just means spread. So the measures of dispersion measure how spread out the data values are from each other. And there's also measures of shape. These values are calculated to measure the shape of the data, and different values can different data sets can have different shapes depending on which values appeared the most often. For example, if I recorded the exam scores of a class and most of the students got scores somewhere in the middle in the C range, and fewer people got low scores like D's and F's, and also fewer people got high scores like A's and B's, then the data would follow a bell shape because there's few people down at the low end and also few people at the high end, and most people are piling up in the middle. But there's also some types of shapes that aren't bell-shaped. For example, if a lot of students did poorly on the exam, then the scores would be piling up at the low end, because we'd have a lot of low scores here, and not very many higher scores. That would be a different type of shape. So what these values actually do is they measure how far off the data is from being a bell-shaped curve. When the data is perfectly bell-shaped, these two values both come out to 0. But when the data is not bell-shaped, these values come out to a higher number. We'll talk more about them later. So this slideshow is going to focus on measures of central tendency only. It'll focus on the mean, median, and mode. Let's talk about the mean first. The mean is just the average of the data. It's the total of the values divided by the number of values. Let's go over an example of calculating the mean. Well, first, let's list out the two steps for finding the mean. You add the values, and then you divide the total by the number of values. Also, we should talk about how the mean can only be found with quantitative data, meaning in order to calculate the mean, you have to have a set of numbers that show an amount or a quantity of something. For example, if you have a list of heights, you could calculate the mean of those heights. If you have a list of incomes, you could calculate the mean of the incomes. But if you've recorded something like a list of genders or a list of hair colors, you can't calculate the mean of those because you can't add them and divide them. So yeah, you can't add and divide a list of categories or words. Let's go through one example of calculating the mean. What's the mean of these 5 numbers? To get the mean, we just add the 5 numbers, we get the total, and then we divide the total by the number of numbers. We have 1, 2, 3, 4, 5 numbers in here, so we divide the total of 36 by 5, and the total comes out to 7.2, and that's the mean of these 5 numbers. And up here, we'll look at how the mean comes out to about the center of these 5 data values. So here's our 5 data values of 2, 4, 8, 10, and 12. The mean of 7.2 is about at the center of those 5 values because 2 values are below the mean and 3 values are above the mean. So I told you the mean doesn't always come out exactly at the center, but it usually comes out somewhere near the center. Here's another example of calculating the mean. We add these 3 numbers, and then we divide by the number of numbers. This time we're finding the mean of 3 numbers, so we divide the total by 3, and we get a mean of 5.3. And once again, the mean comes out roughly near the center of the 3 data values. Here's some important points about the mean. The mean can only be found with quantitative data, like I said. You can find the mean of these 2 numbers right here, but you wouldn't be able to find the mean of these 2 values here because they're not quantitative. You can't add them. So if you have quantitative data, you can calculate the mean. If you have ordinal data, which means you're recording categories that follow an order, like lower, middle, and upper class, you can't find the mean of those types of values because you can't add them. Also, if you're recording nominal data, which means you're recording categories that don't follow any order, like genders or college majors, you also can't find the mean of those because you can't add them. So the mean can be found with quantitative data, but it can't be found with the 2 types of qualitative data because you can't add a set of categories. Also, the mean is highly affected by extreme values, which are called outliers. Here's an example. Here we see that the mean of 2, 5, and 8 equals 5. But what if I change the 8 to an extreme number like 173? This one number would raise the mean by quite a bit. we can see that the mean goes from 5 all the way up to 60. Now let's go over the median. The median, the definition of the median is the middle value of the data. And we talked about how the mean can only be found with quantitative data. The median can actually be found with quantitative data or with ordinal data, and we'll talk about why that's true. Also, we'll talk about how if the data is quantitative, like if it's a list of heights or incomes, you can find the median regardless of whether you have an even or an odd number of values. But if you've recorded ordinal data, such as job statuses or whether people are a child, adolescent, or an adult, then you can actually only find the median if you have an odd number of values. And we'll talk about why this is true also. So first let's start with, well, we'll go through these one at a time. First we'll talk about finding the median of an odd number of quantitative values. Then we'll talk about finding the median of an even number of quantitative values. And then lastly, we'll talk about finding the median of an odd number of ordinal values. So here's our first example of finding the median with an odd number of quantitative values. The steps are putting the values in order from lowest to highest, and then locating the middle value. There's actually no math involved. So what's the median of these numbers? First, we have to put them in order from lowest to highest, right here. And then we have an odd number of values, since there's 5 of them, which means that the median is just the middle value of 4. We locate the middle value, and that turns out to be 4, and that's our median. Here's another example. Here we have 7 values, which is also an odd number of values. We put them in order from lowest to highest, and the middle one turns out to be 6 because there's 3 values below this 6 right here, and there's 3 values above it. There's 3 and 3. So the median is 6. Now let's find the median of an even number of quantitative values. When you have an even number of values, there's actually another step that you have to go through. You still have to put the values in order from lowest to highest, but then you have to find the 2 middle values, because if it's an even number of values, there isn't going to be just one middle value, there's going to be 2 middle values. So what you have to do to get the median is find the mean of those 2 middle values. Here's an example. Here we want to find the median of 4 numbers. We put them in order from lowest to highest. We see that the 2 middle values are 4 and 5. Now we have to find the mean, or the average, of these 2 middle values. To do that, we just add them, and we divide by 2, because to get the mean, you divide by the number of numbers. If there's 2 numbers, like 4 and 5, you divide by 2 to get the mean. And since the mean of the 2 middle values is 4.5, that's our median. So we put the values in order from lowest to highest. We found the 2 middle values, and then we found the mean of the 2 middle values, and then that was our median. This is one more example. Here we have 6 values. We put them in order from lowest to highest. Well, and we see that there's 2 values down here and 2 values up here, which means that 6 and 6 are the 2 middle ones. Now we have to find the mean of those 2 middle values, and it comes out to 6. So that's our median. If the 2 middle values are the same number, then the median will just be that number. And we'll skip over this last example, because it's just showing the same thing. Now let's find the median We already found the median of an odd number of quantitative values and an even number of quantitative values. Now let's go through an example of finding the median of a set of ordinal data. And I said that if your data is ordinal, you can only find the median if you have an odd number of values. And the steps to find the median of an odd number of ordinal values are the same steps that we followed to find the median of an odd number of quantitative values. If you have an odd number of values, you just put the values in order from lowest to highest, and you find the middle one, and there's no math. So what's the median of these 5 grade levels? Well, we need to put them in order from lowest to highest. So we have freshman, 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 and then sophomore and senior. The middle value is freshman, so that's the median. The median of this data set is freshman. Now what about if we recorded these 5 cup sizes? If we put them in order, it'll be small, medium, large, large, large. And the middle one is large, which is our median, so the median of this data set is large. Now why can't we find the median of an even number of ordinal values? For example, what if our data set was large, small, large, large? Then we would have, if we had 4 values, which is an even number of values, we would end up having 2 values in the middle. And the problem is, you can't find the mean of 2 categories. Remember before when we had an even number of numbers, we would find the mean of the 2 middle values to get the median? You can't do that when you have ordinal data. So if you recorded an even number of ordinal values, you're stuck with 2 values in the middle, and you can't find the mean of those 2 values. That's why you can't find the median of an even number of ordinal values. Also, the median can't be found with nominal data, which means you can't find the median with categories that don't have any order to them. When you've recorded ordinal data, like cup sizes, you can order those values from lowest to highest, like we did here. But if you recorded nominal data, like college majors, you can't order them to get the median. If our data set was 5 college majors like psychology, economics, psychology, business, you wouldn't be able to order those values from lowest to highest because those values don't follow any type of official order. So since you can't order a set of nominal data from lowest to highest, there's no median. You can't find the median of a set of nominal data. So here's an example. If I recorded 5 genders, I can't find the median of these 5 values because there's no way to order them. So the median can be found with quantitative or with nominal data. But I'm sorry, the median can be found with quantitative or with ordinal data as long as there's an odd number of values, but it can't be found with nominal data. The median also isn't affected by extreme values. We talked about how the mean is affected by extreme values, but the median isn't affected in the same way. For example, we saw earlier how changing the 8 to 173 made the mean go up by, made it go up from 5 all the way up to 60. But changing the 8 to 173 doesn't raise the median because when the highest value is 8 and when the highest value is 173, the middle value is still 5. So whether the highest value is a regular number like this or an extreme number like this has no effect on what the middle value is. So that's why an extreme value doesn't have such of an effect on the median. If think about the incomes of people in a neighborhood. If one person, if there's a person in the neighborhood who makes 50,000 a year, and that person moves out of the neighborhood, and another person moves in who's a billionaire, that billionaire will raise the mean income of the neighborhood, but that billionaire won't have an effect on the median because the middle value will still just be the middle value. Let's now talk about the mode. The mode is the value that appears the largest number of times in the data, and it can be found with all types of data, nominal, ordinal, or quantitative. Also, we'll talk about how it's possible for a data set to have no mode, one mode, or more than one mode. If every value appears the same number of times, there's no mode. For example, if I'm recording people's college majors and I get psychology, business, and economics, and every value appeared 2 times, there would be no mode because no value appeared more often than any other value. So once again, if I ask 6 people, what's your college major? And their answers are psychology, economics, business, there's no mode. It's sort of like they're all the values are tied. If one value appears more often than all of the other values, then there's one mode. Let's say I ask 6 people, what's your college major? And the answers are economics, psychology, business. Well, then we do have one mode because business appeared more often than the other 2 majors of economics and psychology. There's one value that's in first place. A data set can also have more than one mode. If there's 2 values that are tied for first place, and those 2 values appear the most often, and every other value appears less often, there's actually 2 modes. For example, if I ask 6 people, what's your college major? And their answers are psychology, business, nursing, and economics. I have 2 modes because psychology appeared twice, business appeared twice, and nursing and economics both appeared only one time. So psychology and business are tied for first place. So the 2 modes are psychology and business in that data set. So here's what we just talked about. If every value appears the same number of times, the data has no mode. If one value appears more often than each of the other values, if there's one value in first place, the data has one mode. And if 2 values both appear the most often, and every other value appears less often, the data has 2 modes.